We had a great roundtable today on Reinventors Network looking at disruptive new technologies that could really change the game in the nuclear safety and security and nonproliferation arena. We brought together folks from a pretty diverse set of backgrounds, and we had some really terrific people helping us provide context for all of those technologies historically and looking into the future.
This is a moment where we're poised on the edge of the third age of nuclear weapons. The first age was 1945 to 1989. That was nukes as deterrents. It was a small club, 5 nations. Then we entered a second and very different age. That was the age of nukes as geopolitical prestige. We're in a third age now. It's been called loose nukes or nukes for the rest of us. The danger in this world is that once a non-state actor gets a weapon, there's probably a very strong incentive to use it as quickly as possible because they have the knowledge that everybody is going to be chasing them down to try and get it back. We need new ideas. This is a new world. Are there some technologies that can help with this?
There are 5,000 warheads that are in a state of immediate readiness in the world. They're all being kept up to date by various military industrial complexes. The systems that control them are not being kept up to date. The command and control systems are, in some cases, genuinely mid-60s technology still in effect.
The Soviet Union produced over 100 briefcase-sized nuclear weapons to take out bridges or cities or infrastructure. Approximately 50 of those are unknown where they are at present. So any one of those could turn up in Manhattan at any point and be detonated not by a state actor, but by a rogue individual. And that's not including dirty bombs, which is just taking radioactive material and putting in a conventional explosive and contaminating an area.
We're going to be in an environment where there will be a massive amount of transparency about what's going on. And that's not necessarily a good thing because transparency can actually add volatility to environments. If you know everything that's going on and someone acts in a certain particular way, markets and events can react even faster. So I think we'll have to assemble, in the case of actually having more information, that's great, but we're also going to have to deliver some ways to sort of have pause and not necessarily act immediately on what we learn.
30 years from now, it will be virtually impossible to hide anything. The new technologies that are coming along make possible sort of citizen watchdogs to be added to the monitoring of what's happening not only with nuclear weapons but with the people who control them, whether they be good or bad, governments or individuals.
No matter what technology we have in place, if we don't have our best human decision making at work, we're going to fail.
We're maybe 5 years into the era of big data, and this is very, very early in that space. And what we're going to have at our disposal in the next 20 years is going to be pretty, I think, pretty advanced compared to where we are today.
The thing that's interesting about where we're headed into is the ability to connect these different kinds of sets of information and sort of script those to analytics and AI capabilities. It's an art form that's emerging.
The assumption that we're all making here, it seems, that big data analysis works and will go on working better. I don't find much evidence to support that, actually. I mean, we trust our machines more than we trust our own judgment, and I don't trust our machines anymore. Just because there are more of them doesn't mean that they're any smarter.
You want to pick up a single instance of a person deviating from a nuclear security protocol, I think that's going to be a lot tougher. And I think that if we want to depend on data and sensors to do that, we're going to have to design them to do that.
But by the same token, we have to be absolutely as cautious about what the human brain can and can't do. So it's not going to be a case, I think, of throwing this off to some AI-type machine that will decide, where all the nukes are they in danger, should they be launched, what's the threat level, any more than it should be kind of the same way towards a human doing that same process. So I think what we're going to want to do is really start thinking about the interfaces between both the AIs that we create and also the human decision makers that are around. So it's definitely not an either-or situation.
Well, each age has a new hidden risk. And it feels like the hidden risk here is the tension between imperfect humans and imperfect but ever more autonomous machines. We really have to pay attention to this interface between the machines and humans. And I find that heartening because that's a very solvable problem.
So these kind of things are people problems, just like guns and bullets don't kill people, it's the shooter that kills the people. And the same sort of analogy might be applied to nuclear power, nuclear weapons. It's how these things are handled and not the technology itself.
As we're looking in the next several decades and we're thinking about the people who are kind of going to be in charge, we have to be very concerned about what their capacity to visualize and imagine is going to look like. And we have to be thinking about how do we grab the capacity, the special capacity of humans to empathize and use empathy in moral decision making. How do we use that in a way that intersects with the data and the analysis and the sensors in the optimal way?
At the Global Threats Fund, we work on a handful of big collective action, collective impact problems like climate change, like water, like pandemics. And looking at those issues, I think all of those sectors have done a much better job at incorporating some of the technology pieces, the distributed connectivity. This space just hasn't really done that very well. How do you use new technology? How do you use connectivity? How do you use distributed everything to get new thinking into this arena?
Sensor networks are just going to be everywhere. The data streams that come off of these sensor networks, many of these data streams are going to become publicly available, and there are going to be a lot of opportunities for citizens to, or the general public, or nonprofit organizations to build applications that are analyzing streams of data for patterns in ways that make sense for them to track whatever their interests are.
We had 68,000 active weapons in 1985, and we've only got 5,000 or 6,000 now. Most of those were turned into material to be used in nuclear power plants. We have new methods of understanding the use of nuclear energy that would make it, I think, very practical for us to reconfigure all of that fissile material into energy for the planet at a time when we really need it quickly.
I think that gets us a couple of things. One is it gets us more power relatively cheaply if we can do that, but the second thing is it takes care of a lot of material that's currently sitting unused and potentially can get into the hands of people we don't want it to get into. The best thing we can do is to make that valuable, and you make that valuable by coming up with new technologies that can utilize it. So I'd like to see some of the money getting back into fundamental research to create new ways of utilizing spent nuclear products.
As we move into territory where there are ever more sources of nuclear material, there are non-state actors, there are less clear geopolitics. I think investing now in the human systems, both within our own country and internationally, is really critical.
I think a lot of challenges these days are finding how to smooth that curve out between the infrequent but really high consequence event and the frequent but low consequence events. This has come up a couple of times. I think it comes back that the most promising technology space, in my opinion, is really deeply understanding the interface between our humans and our tech.
As a physicist, there are a few fundamental forces in the universe, and we know nuclear is one of them. Another one is electromagnetism. We started to get very good at understanding electromagnetism and indeed manipulating electromagnetism. We got so good to the effect we can actually replicate human intelligence through the manipulation of this fundamental force. About 50 years after we started getting good at this, we started to break apart the nuclear force and understand what was going on there. From this, we got a crude understanding. From that crude understanding of a very, very powerful force, we were able to create weapons And then later on, effectively using this much like a steam engine, we're able to create nuclear power plants. But we're very, very primitive in our use of this force. For me, over the next 30 or 40 years, one of the fundamental questions is, how much better are we going to get at manipulating the fundamental force of nuclear interaction? And that could go over 40 years. That could take us from where we were with electromagnetism at the start of the 20th century through to 1950, where we got pretty damn good at it. Or it could take us nowhere. And I think as a human species, the real question is, how deep are we going to dive into understanding nuclear forces?